Ma'am, you can start, ma'am.
Good afternoon. I'm not sure who all are online, but happy to answer questions in the last few weeks of optical engineering topics. So I can see Nikhil and Nilanjan online. Do you have any questions? Nikhil, Nilanjan, any questions?
About the Gaussian beams.
Yeah. Yes.
Recently, I was watching your videos on the Gaussian beam. So I have a question about the propagation on the z-axis, which is, as per your advice, is slowed down, and in respect to the wave propagation in x and y axis, which are lateral. So I was having a bit confusion about that. How in the z-axis the propagation is slow in variation? I couldn't get that in the video.
It's not that the velocity is different in these things. It is that, so 1 second, let me share my screen. Are you able to see my screen?
Yes, ma'am.
Yeah, okay. So you're talking about the fact that we have this term. So we are talking about this term actually, right? Which we are approximating in the Gaussian beam context, right? That this is where your question lies.
Yes, ma'am.
So if all that we are saying, oh, I know you're talking about the term when I look at it in terms of wave optics. So I have a dou squared by dou x squared term. I have a dou squared by dou y squared term. I have a dou squared by dou z squared term, and I have a dou by dou z term. These are all the different terms that play a role in the wave equation.
Huh.
Right?
Yes, ma'am.
This is what you're talking about, right?
Yeah, ma'am.
Okay, so we're just saying, if you look at the way the wave is traveling with some variation in the z direction. And that variation with respect to z, this is a slow variation. When we say slow variation, please note, these are differentials with respect to space, right? Not time.
Yeah.
So the variation of the intensity with respect to space is slow. Don't get confused because I'm using the word slow that you think it's velocity. It's not velocity. This is to do with space. So if I were to look at the field here and I look at when I say look at the field, let us say the field is traveling in this direction. This is the z direction. So if I take a cross section of the intensity here. So maybe this is the y plane. So what I've drawn now for you is the YZ plane. Now, if I were to take a cross section, that means I'm looking at, let's say this is Z1. So I'm looking at Z1, and then this is Y1. Sorry, this is Y and X at Z1. Now, if I look at the intensity here, it will have some form like this. It's Gaussian. Now, if I look at the intensity at Z2, and Z2 is very close to Z1. So maybe Z2 is here. If I look at the intensity there, this is at Z2. You may not see the change, There is going to be a small change. But if I'm very close to Z1, that change along the Z-axis is a slow change. That's what we mean by slow. Whereas if I look at the change in the intensity from here to here to here, that's a faster change. That's what I mean by slow here. And since the change with respect to Z
Means
is
the
slow,
variation in the graph.
yes, it's the spatial spread of the field.
Sure.
So we are able to make an assumption because we say it's slow in the Z direction as compared to the X and Y direction. That term where it is the second derivative is going to be an even slower variation, and we can neglect that term that gives us that form. It's a simplified form, which is the Gaussian. Otherwise, a Gaussian would be an even more complicated equation. Does that make sense?
Yes, ma'am.
Yes, ma'am.
Okay. Any other questions? So finally, what you are left with is these terms in your. So if I'm writing with respect to the electric field, this term will exist, this term will exist. This is going to be a very slow, so we neglect this term and this term exists. Did you have any questions on the Oslo tilts? Setting the tilts in Oslo?
No, ma'am.
That was clear?
Yes, ma'am.
You can tell me the difference between local and base coordinate? Can one of you explain the difference, so what you understand is the difference between the local and base coordinates? Can't have an interactive class unless there is some interaction, no? Jerin, Susan, I'm on full screen, so I'm not able to see who's in the audience list. Do we have a few more students?
Yeah, we have about four, I guess, 4 or 5.
So, are there any other questions?
Somebody
Yeah.
was trying to answer, ma'am, but I think there is some audio issue.
Okay. They can even type it. I guess there must be a chat box. One of you will have to read it out. I'm not sure I'll be able to see.
We'll check that.
Yeah. So if you have an answer for that, you can type it out. But in the meantime, please do ask any doubts you have. Jerin, was there anything in the questions online that we could take another look at?
Yeah, we have already answered all those questions, but I will just have a look.
Ma'am, there is a question in the chat box.
Okay, can you read it out?
Yes, ma'am. In one of the last assignments, I think 6th assignment, we are asked to optimize, that is use thickness as a variable and optimize for effective focal length. But how do we do that in Oslo? I opened the operands and went to number 21, but there seems to be no way of typing in optimize effective focal length using thickness as a variable. Ma'am, this is the question.
Yeah, okay. So, I mean, we've been using the operands in Oslo right from beginning, right? You don't have to end. So let me see. I do have Oslo open here. Let me clear all of this. One second. So how does, when we are using the operands, we just pick the operand that we want to optimize. So it may be effective focal length. It may be that we want to, let me actually just start a new file. Okay. So let's say I want to optimize for a particular focal length. So I'm just going to insert some. Okay, so I have, this is a new Oslo file. And let's say I just give a starting curvature of 100 and minus 100, and I'm going to use our standard borosilicate class BK7. I want to look at the image plane, so I make sure that we can see the image surface. And let's make this have a 5 millimeter radius and give it a small field angle of 2 degrees. Now you can see that for this system that I've set up, beams are, the light is coming from infinity. And since I have not put any distance between the last surface of the, you can make this lens more realistic. I can give the lens a small thickness of 2 millimeters. Okay, so I have not, right now the image plane according to this is bang immediately after the lens, which is why this diagram doesn't have any distance after it. So I can solve and say the axial ray is the ray coming from the axial point on the object. And if I have a good imaging system, the axial ray at the image plane should also cross the optical axis. So I'm going to solve. So there are two operations I can do. One is using solves or the other is using operands. These operations are ways of us telling the software to carry out an operation to give us a certain behavior or to carry out a certain function. So we would like, in this case, I'm using a solve, not an operand. And what am I asking the software to do? I'm saying, right now, the image plane has been put right behind the lens. I would like to have the image plane where the axial ray height is 0, where the ideal image plane is. So I'm going to use a solve on the thickness. And what am I solving for? I want the distance at which the axial ray height goes to 0. So I'm going to choose that. I'm going to choose this value 0. And so then if I do this, I refresh this window, you can see now there is this distance of 96 millimeters away from the back plane of the lens. In other words, this is the back focal length of this lens. Now let's say you want to actually design this to have a very specific focal length. So I have 97, but let's say I wanted to make it 100, not close to 100, but I want to make it actually 100. So now what I have to do is I have to go to the operands. Not here, sorry. I have to generate the error function, go to the aberration operands, and I have to choose the effective focal length. So this is the operand that I want, right? Now, what is the value? First of all, I have to set this as 1, otherwise it's not going to evaluate that. And What else do I have to do? How does Oslo know what is the value I want? Anybody? I'm sure somebody else there has done this. So what should I be setting this value as if I want the effective focal length to be 100?
Upper limit is 21, madam.
Upper limit is 21 means? Sorry, I didn't understand that question.
Yes.
What is the question? Susan Jerin, did you get that? I didn't understand. There was something about upper limit.
Ma'am, I think there is audio issue. I'll check the chat box if there are any.
Okay. So can somebody tell me how would I set this effective focal length? What value should I put here so that I can get my effective focal length to be 100? I think somebody must have done this exercise, right? Or give me a number to try. We'll try it out and see what happens.
Ma'am, in the chat box, Sundar is saying that this is the point where he was stuck. I mean, what definition, probably what definition to be made, he was stuck at that.
There must be other people there. So can someone give me a suggestion for what I should put here? What did Sundar
Ma'am,
put?
I also got stuck in this point.
Okay. Sundar, what did you put here? I think, Susan, you're going to have to act as go-between and between the chat box and...
Ma'am, I can see that people are trying to speak, but there is some issue with audio coming in. There is one chat that is, I was expecting an editor where I could select the variables.
So that's what this is, please note, it says operands. Okay, so tell me what they put here and we'll address the issue of variables. You are right. If I want to change focal length, I have to have variables. But note, the operands editor, its role is to say what are the operands you want to optimize. So for example, what are these? These are to do with the ray heights, the marginal ray and the axial ray. These are to do with the aberrations, the third order aberrations or the fifth order aberrations. So if these are all the operands, so in one place you define the operands. I want to make spherical aberration 0. If that were the case, I would say I want to make the third order spherical aberration 0. I'll pick one here, right? I don't have to do anything if I want to make it 0, because by definition, when I select an operand, it's going to try to make it 0. So if I wanted to have some other number, I have to do something. If I wanted to go to 0, I just have to select the operand, right? Right now, we are interested, once I select which operands I want to work with, next I will set the variables, but I don't set that here, I set that elsewhere, right? And I will show you how to do that. So right now we are interested only in effective focal length. So I'm not going to choose a weight of 1 for any of these parameters. I'm going to choose a weight of 1 only for effective focal length. I just want someone to tell me what is the value they enter here.
Ma'am,
Sundar is saying in the chat that he thought he could put just 100 there and would get the focal length as 100. So he's saying that
Okay,
without
let's. Okay, but if I do this, see, Oslo expects you to. It is not going to randomly do this for you. Now, if I select this, I still have to tell Oslo what variable I'm going to use. Now, what are the variables? Can someone tell me what are the variables? What parameter can I change which will control focal length? What are the parameters that will control focal length?
Ma'am, the radius of the curvature.
Exactly. So I want to make, I have put 100 and minus 100 here, but these are the things I will put as variables. So now once I pick my operand, I can go here and I can go and make it a variable. So the letter V will pop up here. I'll go here, I'll make it a variable. Now I have picked these two as variables. Okay, now I have to go to this text window and you can look and see, 1 second, I should be able to see. Yeah, this tells me what are the operands. So there are 21 default operands and you can see none of them have been selected except the last one. Okay, now, but all you have done now is tell Oslo, this is the operand I want optimized. And then you went and you told Oslo, these are the variables that can be, these are the parameters that can be changed in order to get the focal length to be this. And then I will hit the iterate button. Now, if I come here, have I got a change? Has something happened? As you can see, I don't have any change over here. So have I set my effective focal length correctly? Somebody else must have done this exercise. I'm waiting for some comment from somebody else. Has someone else done this exercise? Okay, let me ask this way. When we had done an exercise earlier using the PU command, do you remember? I think that was that maybe the second exercise that we did.
Yeah, second.
Right? So does anyone remember how that was done? I need some feedback because I mean the interactive class is only going to be useful if I get feedback from the students. So I don't want to just do it for you. I want your inputs. I want you to help me do it. What did we do in the when we were using the PU command?
I think, ma'am,
I'm selecting from the optimize option.
Okay, let's go back there again. I go here, I say generate error function, I go here. Okay, then
Now we select the PU command as one.
okay, okay. And, but is that enough?
No, ma'am.
Okay, that's one step forward. What do I have to do there?
Hmm. Now we need to solve something for the thickness, or I can't remember it properly right now.
So that's what I want. I want you guys to
For
solve
the
that
axial
here.
rate.
Okay, let me do one thing because I think my Oslo is having a problem. So I'm going to shut it down and restart it. In the meantime, I'm asking you to solve for the PU command. So there are two ways of getting focal length, right? One is to use the effective focal length, and one is to use the PU command. There's a subtle difference between the two, but I can use both these commands to help me get to focal length of the system. So since you have done the exercise on the PU command, if you need to go up and look it up. In the meantime, I will restart my Oslo. What I would suggest you do is look at the PU command. So remember what you're doing in the PU command. In the PU command, you're saying what is the angle this ray should make. So if this is the back surface of the lens, the PU command is saying, I want this angle, let's call it U, to have a value such that this has a certain distance. So with the PU command, we are actually setting the back focal length of the lens. Right? So I think let's say this is 5, which in what I set for this system, and I'm saying this focal length is f. So can you calculate and tell me what is the value that PU, what should I set for PU? And in that way, I'll be able to control the back focal length. Okay, so can you do that calculation? I'm going to restart my system and restart Oslo. And then we'll look at what happens when I use the PU command. You're going to tell me what that value is. And what is the difference when I set the effective focal length. Okay. So who's going to give me the PU command? One of the students there. Okay, just give me a few minutes to restart Oslo while you calculate what is the value for the PU, and please feel free to go look at that exercise again. That was already some 4 weeks ago or 5 weeks ago, so you should know how to do that. Do that, then we'll come back and do it again in Oslo. Well, let me just reset my is the screen sharing still going on? I'm not sure if Zoom something seems to. Is the
No,
screen sharing
stopped.
stopped?
Yeah, it stopped.
Okay. Okay. Let me anyway restart Oslo, and then I will share. Jerin, Susan, you can also calculate it and keep it. Hopefully, the students will do, but in case not, we can give them the number.
Yeah. Okay. No, ma'am, you are not audible. Can you hear me, ma'am? Ma'am will rejoin soon, okay?
Am I audible now?
Yes, ma'am,
Yes,
you're
ma'am.
audible.
Okay, okay. I was trying for some time, but I think no one could hear me. Okay, let me start with the screen sharing again. 1 second. Okay. So does somebody have a calculation for me for PU value? Okay, let's do it this way then. Any questions with what I've done, with the settings I've done so far in Oslo? Is there any question here or is this clear? I have a lens. Right now what I've done is I've put 100 for the curvature of the first surface, minus 100 for the second. I'm given the lens a thickness of 2 millimeters. BK7 is the glass. It's a borosilicate glass. And we've used a solve which makes the axial ray height. We're choosing this distance so that the next plane is where the axial ray height goes to 0. And that's what we can see over here. And this is giving us an effective focal length of 97 millimeters. Now, what is it that we want to do, or what is the exercise? We may be asked to set effective focal length. We may be asked to set the back focal length. So let's look at effective focal length first. If I go to optimize, generate error function, The first thing I'm going to do is to pick the operand of interest. So let's say I pick 1, this effective focal length here. I have to make the weight 1. Now, at this point, can anyone tell me how does Oslo optimize these operands? Does anyone know? I already told you a few minutes back. What does Oslo do? When I say optimize, what is it doing? Any clues? It's okay if your answer is wrong. Just try. Tell me what you think. Is it making that value 0? Is it making that value the value you set it? What is it trying to do?
I'm setting an optimal value in
But
respect to the variables.
But what is an optimal value? When I say focal length is 50 degree or focal length is 50 centimeter or focal length is 100 centimeter, focal length is 30 centimeter. Oslo cannot decide what is optimal value, right? You are deciding for your system, I need a focal length of 100 centimeters. That's your value. No, the software can't tell you what is optimal. So what do you think you set in the operand here? Do you set the value you want it to achieve, or what? We discussed this in an earlier class. You have done this with the PU operand. So what is it trying to do? What is it that we're setting over here? Okay, let's try. I'm going to set 100. Let us say we want to get a focal length of 100. So I set this equal to 100. Okay, so let's accept that. Now, I can set operands. Unless I set variables, nothing is going to happen. So I have already set these 2 radii of curvature because we know that focal length 1 over f can be considered to be n minus 1, where n is the refractive index of the material of the lens, 1 over R1 minus 1 over R2. Now, we're not going to be playing around with the material of the lens. It's not impossible to do, but it's a harder thing to do. So assuming, and we have said we're using BK7. So that's going to have a certain fixed refractive index. So we're not changing refractive index. This is a constant because we have picked the material we're working with. But we can say, let's pick a lens made out of BK7, which has these radii of curvature. The variable or the parameter that we can choose is changing the radius of curvature. So we are going to keep this and this as variables because we know they will affect focal length. So that's what we've done over here. We have selected the the radius of curvature of surface 1 and surface 2 as the variables. Now, if I go here again, I can look at which are the operands. I'm not trying to optimize anything else. I'm only trying to optimize effective focal length. If I iterate, some iteration happens. But when I look over here, I don't see any change. So this is what I've been asking you. Have we set the operands correctly? So let's go back to our operands, right? And let's see. We set this as 100. But the way Oslo wants you to set the operand is, or the way Oslo is set up, it always tries to minimize the operand. So it is going to try to make the operand 0, which means you want this to be OCM 21 minus 100. So it will try to make OCM 2100 such that this difference is 0. So let's see if this works now. Select this. Again, I can check what are my operands. Or in fact, let's just clear this. Okay, so now my operand is OCM 21 minus 100. Now let's iterate. And when I iterate, now you see that these two radii of curvature have changed and the effective focal length is 100. So what were the steps we were doing? We picked the operand that we wanted to optimize. We then went back to the lens editor, the surface data sheet, and we picked the variables we wanted to use in order to optimize that. And then we come to this window over here and we use the iterate button. We have to put value of the operand such that when that value is minimized, it is made to go to 0, we will get our value of interest to have the desired quantity. So since we wanted a focal length of 100, we wrote, let this be OCM 21 minus 100. So what the software is doing, it's making OCM 21 equal to 100 such that this difference becomes 0. I can go back to the operand, right? I can go back and say, I want a focal length of 80 millimeters. Okay, now let me iterate. Now you can see that the effective focal length has become 80 millimeters and the radii of curvature have changed. Okay, so it's a multi-step process. Now the reason I had asked you to tell me about the PU operand was in that exercise, we very clearly made it clear, you want the angle to have a certain value. Then we didn't just write the value of the angle here. We wrote OCM2 minus that angle. Again, that means it will optimize the value of OCM2 such that OCM2 minus that angle goes to 0. Is that clear now, or is there still a doubt there?
Clear, ma'am.
Okay, so it's a multi-step process. Now, can someone tell me, I wanted the effective focal length to be 80. Why is this value 79 here and why is this 80 here? Why is this not 80 here? And if I make it 100, maybe the difference is even more visible. Let's go back to, let's make it 120. So let's say I wanted a focal length of 120. I don't know, maybe it's not that much of a difference, but I want a focal length, effective focal length of 120, and I have got an effective focal length of 120. But why is this value not the same as this value? Why is there a difference? Are these two the same? Is this distance here and is this actually equal to the effective focal length? Or does it have some other term? We've discussed this in some of the earlier videos. So if I have a lens, so let's say I have a collimated beam of light coming and I have a lens and this is my optical axis and these rays are focusing here. Now, what is effective focal length and what is that distance that is given in the in Oslo? What is this distance? And what is this distance? With respect to this image. Try, I'm sure you have looked through the video, so you can try and give me an answer. Okay, if I set this as 0, then what happens? Let's optimize again. So what did I do? I set this as 0. By setting this as 0, what have I done? What is that thickness I set as 0?
Thickness of the lens.
Okay. Now, is there a difference between this number here and this number here? Okay, this is a simple yes and no answer. Somebody has to answer me here. Come on. Is this number the same as this number over here?
No, ma'am.
This number is not the same. This and this number. I'm asking about this effective focal length and this distance after the second surface. Are they equal now?
Yes, ma'am.
Does everybody say yes? Because I heard one no earlier. Susan, Jevin,
Yes, ma'am.
please tell me there are some yeses in the chat box. Otherwise, I'm going to start weeping over here. Are there any comments in the chat box?
Ma'am, no, ma'am. There are no comments, new comments.
Okay, so I hope everyone can see the effective focal length has now become equal to this distance. In other words, in this figure, this I can think of my lens, parallel set of rays coming into my lens, and these parallel set of rays are, or rather, actually, let me draw it like this. I can consider my lens to be a straight line, and these rays are coming to focus here. This is that distance of 120 mm. Why am I drawing it like this and not like this? Because in the second setting, I have made the lens thickness 0. So it's as if the lens is a straight line. When I make the thickness 0, the effective focal length and this distance, what is this distance? This is the distance from the back surface of the lens to the focal plane. When the lens thickness is 0, these two distances are the same. Now, let's go back to the case when this is not a thin lens, it is not this imaginary thin lens which has no thickness. Let's give this lens a thickness of 4 millimeters. Now, think about this. The light is coming from infinity. The lens has a focal length of about 120 millimeters. I have made the lens 4 millimeters thick. So compared to 120 millimeters, that's the distance of the focus. 4 millimeters is a small number. That's why I still call this a thin lens. But if I look now, I can iterate once again. I can make the effective focal length 120, but I see that there is a big difference here. Now, having done this exercise of changing lens thickness, can you tell me why there is this difference between effective focal length and this distance over here? Have you heard of something called back
Due to
focal
the
length?
difference, due to the back focal length and the effective focal length.
So I can, because of the thickness, I'm actually now, so what is this 120 mm then? Where is it being
Effective
measured
focal
from?
length.
That's correct. Where is it being measured from? This
From the
118
center of the lens
millimeter.
on the optical axis.
So let's go back to this figure. Let me draw this better. This is my optical axis. This is my lens. It has a certain thickness. So I'm going to draw it like that. Okay, it's symmetrically placed about the optical axis. I have rays coming in from infinity, and they're being focused over here. This distance is 118 millimeters. About, it's a little more than that. It's 118.67 millimeters. So, but we are being told that the effective focal length is coming from somewhere here. This is 120. Now, what is this plane? Am I randomly choosing some plane? What is this plane? We have a whole class on this, a whole video on this, 1 or 2 videos on this. What is this plane called? Where's that distance being measured from? Do you remember that we talked about the principal planes?
Yes, ma'am.
So isn't this one of the principal planes?
Yes,
Oh,
ma'am.
sorry, I've spelled this wrongly. For a thin lens with thickness 0, the principal planes, the center of the lens, everything lies in the same place. So the back focal length, front focal length, effective focal length, they're all going to be the same. But the moment I put thickness into the system, the lens thickness, or the lens has some thickness, the effective focal length is always measured from the principal planes. How do I know where are the principal planes? So if I take a lens which has thickness, if I take a lens which has no thickness, I can draw it as a straight line. And if I do that, then let's say I have a point here, and let's say this is focal length. Any ray coming from this point, they will all emerge parallel. Because this distance, this point is focal distance away from the lens. Now, because I have drawn my lens with a straight line, and I can do that if I make the assumption the lens thickness is 0, then the ray that hits the lens here emerges parallel from the same location. The ray that hits the lens here emerges parallel from the same location. And in a sense, this is how I define focal length, or the effect of focal length on a system, right? If I have, this needs to go through the center of the lens, 1 second. So if my optical axis is this, now I draw up rays coming from the effective focal length. So this is the effective focal length, right? This is a ray coming from the effective focal length. This is a ray coming from the effective focal length. They're all hitting the lens. Now I know that this ray eventually has to come out parallel, because rays coming from the focal point will have to come out parallel. How do I find the location of the principal planes? Well, I will trace this ray, I will trace this ray, and I will get the intersection. I will trace this ray, I will trace back this ray, I will get the intersection. I do that for all the rays, and I plot this. I'll join these up, and where it crosses the optical axis, this is principal plane 1. I can repeat the exercise having parallel rays come in from here. These rays then have to focus at the focal point here. So this, right? And if I repeat the exercise, trace these rays forward and trace these rays backward and mark the intersection points, then this will be principal plane 2. Is that clear?
Yes, ma'am.
Is that clear for everybody?
Yes, ma'am.
Okay, in this figure that I've drawn, what is the back focal plane? What is the front focal plane? What is the effective? What are all the distances? Let me
From the
label.
principal,
I have A. Let me help you. I give you A, B, C, D, E, and F. These rays are coming to focus here, let's say. Okay, so I hope that's clear. This point is A. This point, where the optical axis crosses the front surface of the lens, I've labeled as B. The principal plane crossing the optical axis is C. Principal plane crossing the second principal plane crossing the optical axis, that's D. Back surface crossing optical axis, that's E. And this focus here is F. Now can you tell me what distance corresponds to effective focal length? What distance corresponds to front focal length? What distance corresponds to back focal length?
ma'am, AB corresponds to front focal length and EF
Okay,
corresponds
good.
to back focal length.
Very good. Effective focal length?
And AC and DF are effective focal lengths.
Excellent. So AC and DF are effective focal lengths, and in fact AC will equal DF because the effective focal length of the system is one value. The system has a certain amount of power, so that it's not a certain amount of power if you come from one direction as opposed to another direction. The power of a system is determined by the refractive index of the materials in it and the radii of curvature. Those are constants. So there is only one power associated with an optical system, and therefore only one effective focal length associated with an optical system. However, front focal length and back focal length may not be equal for a system. Depends on the system. They may not be equal, but AC and DF will always be equal. I hope that's cleared up some doubts. Students are quite hesitant in giving answers. So I hope that's more because you're feeling somewhat awkward and not because the material isn't clear. But, please do ask questions in the forum, and in these sessions, ask questions, clear your doubts. That's the purpose of these sessions. Are there any more questions?
Ma'am,
Ma'am, if
Yes.
in a question the back focal length and the effective focal lengths are given, then we can calculate the front focal length if asked using the matrix calculation, right? For compound lens.
Sorry, what was the question? You're being given the back focal length.
Yes, ma'am.
And the
Ma'am, maybe 2 or 3 unknowns and the effective focal length, like that. And few unknowns and few knowns, and you have to calculate the unknowns.
if you know the ABCD matrix, you should be able to calculate. Yes. Because from the
Okay, ma'am.
ABCD matrix, you can get the location of the principal planes. If you know the location of the principal planes, then yes.
Okay, ma'am.
Susan, is there some other question you were going to from the chat?
Yes, ma'am. There is a chat that is in one of the assignments. You had a sphere with 2 different hemispheres of different refractive indices. Can we take the average of the refractive indices for working out effective focal length?
I don't remember the exact problem, but average sounds wrong straight away. Susan, Jerin, do you remember what the problem was exactly?
Ma'am, we had given a question on a spherical ball, wherein
Oh, the lens is a ball, like a ball.
Yeah, lens.
The lens is
Having
like
2
this.
different refractive indices.
So this is N, this is N2. What do you think? Why would you take average? What would you do? I mean, forget the, we took the lenses to be like 2 halves of a sphere. What if I given a problem like this? This is N1, this is N2, this is F1, this is F2. Would you have taken the average then? Isn't this and this sort of identical problems?
Yes, ma'am.
They're identical problems. Only thing is, this is a Plano convex lens. This is a Plano convex lens. Why do I say Plano convex? This side is planar. This has radius of curvature R1. This is also Plano convex. Since if we took a perfect sphere, this means this is same radius. So it will be minus R1. But the focal length will be different because the material is different. And if I have taken a sphere, it means I can't neglect the thickness. It's going to probably be quite a thick lens, right? Because normally when we take a lens, if that is a sphere, we are normally taking this region to be the lens. So, that's the thickness. Now we are saying this is the thickness. So it's quite thick. So you have to take into account this thickness, but you would not take average, This is a lens, the first lens. It has R1, it has infinity for the radius of the curvature here, and sorry, the radius of curvature here, and the material is N1. So and its thickness has some value. And similarly for the second half, right? You treat it as 2 different lenses put into contact with each other. These are problems that you can easily put into Oslo. Put them into Oslo and see what happens. And you can in Oslo, we go here and I type BK7, but you can also go and choose you can go and put a material of your choice with a refractive index of your choice. So you can go and try this out, and best thing is to try these things out. Play with Oslo. It's easy to play with. And all the reason we teach the optics along with this is because it helps you develop the techniques we're learning or the principles we're learning. You can use the software to immediately test them out. Okay, I see we have crossed 1 hour. If there are no more questions, shall we stop here?
Ma'am, I have a question.
Yeah. Go ahead.
Ma'am, regarding the pencil curvature in the
Yes, go ahead.
ma'am, regarding the astigmatism and the pencil curvature that you mentioned in the aberration section of this course,
Yes, yes.
astigmatism and pencil curvature.
Yes.
Ma'am, in the astigmatism, the sagittal rays and the marginal rays can be interchanged if the the lens is spherical. Ma'am, what if the lens is nearly spherical,
Sorry,
and if
sorry,
we try to interchange,
sorry, say that again. I missed the last part. If the
ma'am, if the lens is perfectly spherical, I mean circular in nature, we can
I'm sorry, I'm not able to hear him. Is someone else able to hear clearly?
Ma'am, I think the voice is broken for him.
Yeah, okay. I also didn't catch that.
It's lost. I'll check whether there is any chat.
Yeah. Even if we can't answer now, he can put the question on the forum. We'll answer it there.
Yes, ma'am.
Is there any other question while we wait to see if he's able to come back and ask? Anybody else?
There was a question which was been asked a bit earlier. It was regarding optimization, I think. If I want to maximize or minimize an objective function of some variables while constraining the values of other variables, I mean, he's asking whether he will be able to do that in Oslo. Sundar is asking.
Yes, you can do that. You can do that. You have to set up your operand. So like I said, there are 21 default operands there. You have to write your operand in such a way that it happens. It is possible. It's not one of the default options, but it is possible to do that. You can go and make an equation. You can insert an operand of your own definition. That so you there we have put you have, but of course you'll have to define that operand in terms of parameters that Oslo is measuring. It's possible, and also one aspect we don't cover in this course, you can actually do programming with the software. Then you can take any of the parameters that Oslo measures and use them to set your own code and to minimize something and maximize something. But we don't cover any of that in this course, but yes, it is possible.
Hello, ma'am.
Okay, I think, yes.
Am I audible?
Yes, now you're
sorry,
audible.
I was disconnected for a while. I got
no problem. No problem.
So ma'am, I was asking about astigmatism. In that section, it mentioned that if the lens is quite symmetrical in circular manner, then there will be astigmatism, right? And you can interchange the meridional plane and the sagittal plane.
Yes, if you're looking at an on-axis point, that is true. Yes.
And ma'am, in the sagittal planes and the meridional planes focuses in different positions, so it gave rise to astigmatism. So if I'm asking that if I
sorry, go ahead.
Now if I change the image plane with some angular deviation, then can we minimize the astigmatism error? Means if it is dynamically moving the secondary image plane according to the focal lengths or the focus points of both planes in some angular deviation, so we can minimize both the effects.
First of all, Are you talking about an on-axis point or an off-axis point?
Ma'am, on axis.
If it's on-axis and you have a circular lens, you will not have any astigmatism,
Okay, ma'am.
right? Because think about it. If I have an on-axis point, so this is my optical axis, I'm looking from the side. This is my lens. And let's say I have my object here. Now I have a ray that goes to the top of the lens. And it is coming image somewhere here. Now, if I were to redraw this image, but instead of looking from the side, I looked from the top, would this look any different?
No, ma'am.
Won't it look exactly the same? For an on-axis point, if I draw the ray going to the top of the lens, now if I look from the top, and so this was the side of the lens, this is the top of the lens, but it's circularly symmetric. If I look anywhere around the lens, it should look the same. Now I'm drawing the ray going to the extreme. So if I were to sort of try to draw this lens in 3D, this lens is going to be something like this. And in this top image, I'm drawing the ray to the top of the lens. In this side image, I'm drawing the ray going from here to the side. So if I look at the front view of the lens now, in this image, I'm drawing the ray that lands up here. In the side image, I'm drawing the ray that lands up here. But if the ray is coming from, this is the optical axis, I can't draw it in this view, but the object point lies along this optical axis, some distance away from the lens. So imagine that it is a few centimeters above the lens. So it sees the lens completely symmetrically, right? So there will be no astigmatism in that case.
Okay, ma'am.
Okay, I think we can call a halt. I'm glad that finally there were some questions. Again, please do come to the interactive sessions and interact, and also keep putting up your questions on the questions area in the course on the online site. And my TAs will get back to you with answers, and I mean, if necessary, I'll also step in to help with answers. Okay, then. Thank you. I'm assuming, Susan, there was nothing more in chat.
No, ma'am. There are no other questions.
Okay. So in that case, thank you.
Thank you, ma'am.